Welcome to this explainer. Today we're going to be breaking down a totally fascinating yet pretty much invisible system that literally makes our modern world possible. Most of us never really stop to think about how the raw materials for our electronics, or our medicines, or just everyday goods actually travel across the globe. But today, we're peeling back the curtain to explore the hidden architecture of global trade. We're going to look at the engineering, the operations, and the risk architecture that let the absolute most hazardous cargoes on Earth move safely across our highly connected world. Let's get right into it. So I want to start by posing a massive logistical puzzle. It's one the chemical industry actually faces every single day. Just imagine, for a second, the sheer danger of transporting 25,000 liters of sulfuric acid. That is a lot of acid. You have to move it thousands of miles. It's going to transition between trucks, ships, and trains. And yet, here's the kicker, the cargo itself is never poured, it's never pumped, and it's never transferred from its original container during that entire journey. So how on earth is that level of seamless, incredibly safe transport actually achieved? Well, the answer to our puzzle is something called the ISO tank container. It's an invention from the mid-1960s, and it fundamentally reshaped global trade. Honestly, when it was first introduced, it didn't look all that revolutionary. There were no flashy complex electronics, no complicated moving parts, but this pressure-rated, globally standardized intermodal solution meant that chemicals, food-grade liquids, and all sorts of specialty products could suddenly move straight from a factory gate all the way across the ocean directly to a customer. And it did this without any repacking or unnecessary human handling whatsoever. Now, to truly grasp global liquid logistics, you really have to undergo a bit of a paradigm shift. You have to stop looking at this thing as just some simple container or, just a stainless steel cylinder sitting inside a steel frame. What it actually is a highly engineered intermodal pressure vessel. It's specifically designed to transport incredibly hazardous cargo safely across multiple different modes of transport, all while strictly complying with a whole web of international regulations. It is, absolutely, the backbone of global liquid logistics. And the genius of the design is really in its simplicity. Think about the outer steel frame, and more specifically, those four simple corner castings. The tank itself doesn't have an engine, right? But it connects to literally every port, crane, and chassis in the entire world through those standard corners. It's like a giant puzzle piece. The exact same crane and the exact same truck chassis can lift and secure any ISO tank container on the planet, completely regardless of who actually built it or which operator happens to own it. Section 1. The problem with drums? Okay, so let's picture what things were like back in the day, before this standardized system existed. Bulk liquids used to move in drums, flexi bags, road tankers, and parcel tankers. And the big issue here was that every single transfer step was a huge risk. Every time you physically handled the cargo, you opened the door for chemical contamination, product loss, crazy delays, or even a full-blown disaster. Actually, spilled cargo and ruptured drums used to just be considered an inevitable cost of doing business on the waterfront. Wild, right? Because of this, dangerous goods were severely constrained by geography and cost, mostly because you needed highly specialized waterfront labor just to handle them. Basically, hazardous cargo meant complexity, and complexity meant strict limits on what you could actually trade globally. This brings us to a crucial point, which is summed up perfectly by this idea. Standardization changed the fundamental unit of trade from a specific tank to an interchangeable asset. Before this happened, every single tank and fitting was basically a negotiation. A tank built by manufacturer A couldn't easily interface with a crane built by company B. But by establishing one global standard, the physical interface became completely universal. The tank itself almost became invisible to the broader system. Suddenly, only the cargo and the compliance mattered. Section 2. The power of standardization. So let's walk through this intermodal journey. First off, the tank is secured onto a standard truck's chassis. Second, it arrives at the port where it's lifted by a standard port crane. Third, it gets secured directly onto a ship's deck. And finally, when it arrives at its destination, it transfers seamlessly to a rail network, or maybe another truck. Because of those standardized corner castings we talked about earlier, a shipper over in India and a depot in Rotterdam can rely on the exact same equipment without ever even speaking to each other. It's just a completely frictionless transfer across different modes of transport. But here is a really critical concept to grasp. Probably the most important takeaway. The tank container didn't just magically eliminate risk. You can't just erase the danger of moving hazardous chemicals. Instead, it reorganized it. And that is a massive shift. It means the responsibility moved away from the manual handling of waterfront labor and shifted heavily towards strict inspection protocols, engineering design codes, and really rigorous testing. The safety of the cargo now depends entirely on the structural integrity of the vessel itself and the systems built around it. To actually make this reorganized risk model work on a global scale, the industry had to build a massive compliance ecosystem. We are talking about dense international rulebooks that govern dangerous goods. You've got the IMDG for maritime shipping and ADR or RID for European road and rail. There's also the CSC, which is an international convention that ensures structural safety. Ports had to evolve into these highly controlled facilities, and cleaning stations, they became absolutely critical infrastructure. This whole ecosystem created a universal, standardized language for things like safety valves, pressure relief devices, and inspection regimes that is completely understood across every continent. Section 3. The closed-loop jury. Now, because their journey is a closed loop and not just a straight line from A to B, understanding the life cycle of a load is super important. Step 1. The tank departs the depot. It's completely empty, but crucially, it has been rigorously cleaned, tested, and surveyed. Step 2, it arrives at the manufacturer's plant where it actually gets loaded with cargo. Step 3, it's delivered via that totally seamless intermodal transit we discussed, right to the consignee or the customer. But step 4 is where it gets interesting. Once it's emptied, it doesn't just sit there. It has to return empty back to the depot for cleaning, inspection, and repair. The operator has to meticulously manage the asset because you see, a tank is never really delivered and done. It's just constantly circling back to start the whole cycle over again. But of course, every single stage in this cycle is a potential point of failure. The chain can break literally anywhere. At the depot, maybe it's just a missed gasket or some hidden pitting in the steel. At the plant, someone might accidentally load cargo into a tank that has expired test dates. Out on the road, a driver might prematurely peel off those dangerous goods or DG labels, completely breaking the safety information chain. And then at the gate, a surveyor might suddenly be faced with undocumented cargo residue. So, while the physical tank is brilliantly standardized, human error can still easily compromise the entire system. And that brings us to a really vital realization. The missing piece to making this incredible system foolproof isn't thicker steel or better valves. It's shared operational understanding across the full tank journey. Dangerous goods awareness simply cannot stop at one single company's fence line. The plant operator has to understand the tank equipment, the depot team has to understand the specific cargo history, and really, everyone in the loop needs to see the big picture. So I want to leave you with this provocative thought to chew on. Does the driver truly understand the surveyor's risk at the depot gate when those safety labels are removed too early? It's a question that forces us to really consider the critical human element required to safely run this massive, hidden automated system of global trade. The ISO 10 container absolutely connected the world, but at the end of the day, it relies on an unbroken chain of human competence and shared understanding to keep us all safe. Thank you so much for joining me for this explainer on the fascinating world of tankology. Keep wondering, keep learning, and I'll catch you in the next one.